Okay, well, we're not going to do that today, but let me take you back then. So this new model, this very, very exciting new model, which you believe you have the evidence for, of this universe expanding out of control much faster than we thought, why does that mean the end of us? Why does that mean it will all go dark and cold?
Well, even 150 years ago, thinkers like Charles Darwin, or more recently Bertrand Russell, wrote about the fact that physics does seem to say that the universe will eventually run down. It rusts. We have what is called the second law of thermodynamics. Chaos takes over. Stars blink out. Stars get cold. The oceans will freeze over, and we'll all die in a big freeze. And Charles Darwin wrote in his autobiography, what an unpleasant thought, that evolution, that we struggled to get out of the swamp, every layer we struggled with is all for naught. Why bother to wake up tomorrow morning? Why bother to go to work, knowing that we're all going to freeze to death billions of years from now? Well, now we actually have an exit strategy. You mentioned George Bush. He has to ponder when is the situation cool enough in Iraq to exit troops. Well, we physicists believe that our universe is cooling down too rapidly, that it is out of control, that we are in an accelerating runaway universe.
You said the laws of physics have signed the death warrant for our universe. We are
in some sense, there seems to be a death warrant for our universe. And again, it'll be billions of years from now. But what a thought, knowing that all the achievements of humanity will eventually crumble when the universe itself begins to crumble.
Gloomy, pessimistic thought.
Well, when we physicists give talks, we get asked very embarrassing questions. Like, for example, Professor, what happened before the Big Bang? Well, the answer to that is the multiverse. The other embarrassing question we get is, this is all very depressing, hearing that the stars will blink out, the universe will consist of black holes, the oceans will freeze, the night sky will be dark. There will be no stars to guide us at night. What a horrible thought. And my attitude is that the laws of physics do have an escape clause by which perhaps we may have to go through this umbilical cord to perhaps journey to another universe.
Now, explain, because one of the most difficult concepts to grasp in your book is this question of parallel worlds and where they are, where these other dimensions are. Everybody knows something is wide and tall and understands the concept of time, but where's this parallel universe?
They're actually in our living room. When I was a child growing up outside San Francisco, I used to look at the carp in the Japanese tea garden. I used to spend hours imagining what would it be like to live in two dimensions. A very shallow pond, fish could swim forward, backward, left, right, their eyes were to the side, but the concept of up into the third dimension, up into hyperspace made no sense to any fish. And I imagined a scientist there saying, bah, humbug. Anyone who talks about the world of up is talking science fiction. And then I imagine as a child grabbing this fish scientist, lifting the fish scientist into hyperspace, where the fish scientist would see other ponds, parallel ponds, beings moving without fins, beings breathing without water, that is us, a new law of physics. Now, H.G. Wells, in his novel, The Invisible Man, no one ever reads it carefully to find out how H.G. Wells envisioned invisibility. He envisioned it through the fourth dimension. If I have two parallel sheets of paper, like two ponds, I have us in one universe, but I have another one hovering, just hovering inches above our universe. Light goes underneath the invisible man, so he is invisible, but he could look down on us. So we think that anyone in a higher dimension could be visible to us via its gravity. Gravity does seep across universes.
So by being visible because of its gravity, there may be a way of proving that this theory is more than just a theory.
That's right, and believe it or not, the Hubble Space Telescope over the last several years has been giving us maps of something called dark matter. Dark matter makes up most of the universe. It's not made out of atoms. Your chemistry teacher was wrong in saying that the universe is mainly made out of atoms. You are going to
get burned at the stake, I can see. All like chemistry. Anyway, go on.
The whole generations of textbooks have now had to be thrown out. The universe is not mainly made out of atoms. We are talking about dark matter. It's invisible. You cannot photograph dark matter. We know it's there because of its gravitational presence. The Hubble Space Telescope has indirectly given us maps, gorgeous maps of dark matter pervading the galaxy. Well, some of us believe that we are actually tracing out the outlines of the invisible man, invisible galaxies, invisible worlds hovering just above our universe. Invisible because light goes beneath it, but we feel the effects of its gravity, which hops across universes.
Which can be measured. But then,
Can be measured.
But then, if that is true, at some point, some scientists somewhere will find a parallel universe, will they not? And they are searching for it.
We think that, first of all, you can detect a parallel universe in several ways. First of all, how does a parallel universe form? Everybody knows that when matter falls into a black hole, it disappears. But, even children ask the question of their parents, gee, Daddy, if all that matter falls into a black hole, where does it go?
Which is a good question.
Some of us believe that it's blown out the other end, that it goes through the kitchen sink, but then it's blown out into a white hole. Now, a white hole emits matter rather than swallowing it up. A white hole expands very rapidly to accommodate all this new matter flowing into it. And hey, doesn't that sound like the Big Bang? Doesn't that sound like Genesis itself? Our universe could be a white hole. A white hole expanding rapidly with matter flowing into it, connected by an umbilical cord to perhaps a parent universe.
Now, when it comes to these umbilical cords, explain then, as you say, if our universe is expanding rapidly and out of control, it's going to end up cold and dark and miserable.
That's
we have
right.
a choice of dying or what?
Well, as Woody Allen once said, eternity is an awful long time, especially toward the end. Well, toward the end, in my book, Parallel Worlds, toward the end of my book, I actually give a blueprint of what would it take to open up a looking glass. Now, remember that Alice in Wonderland was written by Lewis Carroll, an Oxford mathematician known as Charles Dodgson. He knew that universes could be glued together at the hip, like Siamese twins, and he called that the looking glass that allowed you to see into Wonderland. Now, we physicists think we could do it as follows, by boiling space. Now, when you boil water in a microwave oven, you turn up the heat and water forms bubbles inside the water. Well, if you boil space, if you heat space up to what is called the Planck temperature, the temperature of the Big Bang, bubbles form. These are bubbles in space itself, tears, rips in the fabric of space and time. They are looking glasses into these other worlds, connected by umbilical cords to our world. And so we realized that there could be an escape hatch, and
For mankind, for everything that we know, not the depressing scenario you talked about that Darwin painted and others, Bertrand Russell had painted. There may be a way out.
there may be a way out, that the laws of physics are not a death warrant, as Charles Darwin thought, as Bertrand Russell thought. We believe that perhaps we now have for the first time a loophole in the laws of physics, that we may be able to boil space, open up these looking glasses, and perhaps in a civilization many years more advanced than ours, go and flee into a warmer, younger universe. This may be our only hope far into the distant future.
Can you see, I want to talk a bit about the impact on humanity and ordinary people, but can you see why, to many people listening to this, it is almost as if theoretical physics has become a new priesthood, because you can make the calculations, you speak this, you're translating your technical language for the benefit of all of us, and we have to take it on trust that you've got it right, and this theory, perhaps, may be the right one.